So I'm going to be going over question 9. So question 9 says the following. In the diagram below, which is actually that one there, O is the center of the circle. So O is the center of the circle. P, R, S, and A are points on the circumference of the circle. So that's a cyclic quad over here. Okay. And now, let's say over here, AOBC is a straight line such that the B lies on PS. So AOBC, where is AOBC? AOBC. So AOBC is this straight line right over here, such that B lies on PS. So B will lie on the line PS over here. And with PB over here, we're being equal to, so PB being, why did it do that? PB being equal to BS over here. And A1 is equal to X. So that's the information they give us. Cool. So over here, what they're saying is that because this is the circle center, and I was like a little bit confused at first now that I looked at it. This is the circle center, they told us. That means this must be equal to another line, which is going to be this over here, right? Because these are radii. And I was looking at this and I was thinking, what on earth? That is not, those can't be radii. And it's probably not. But for now, these are going to be equal to each other because O is the circle center and we have an actual radius over here. Okay, so now let's start with answering the question. So 9.1 says, determine with reasons P1, angle P1 in terms of X. So we need to determine angle P1 in terms of X. Okay, so let's start by saying the following. Okay, so the way we're going to start is the following. And what I actually see over here is that this is also a radius, right? So let me actually get rid of this radius since it's not really benefiting us, since it's actually cutting through our angle P1. So I thought that maybe we would use that at some point because once again, it's a preliminary paper and I'm always expecting the worst. But right now, what we can see is we have two radii, right? And what that actually how that actually benefits us is that then because those are radii, right? So we can actually first start by saying that that OA is equal to OS, and this is because they are radii, right? And now the next thing we can say is that angle A1 is equal to angle S1. So angle A1 is equal to angle S1, which is equal to X, right? Because they told us that it's X. And this is because it is angles opposite equal sides. Okay. And now, from here, what we can do, because we have these two angles now, which is going to be X over here, we will know that this angle here must be an angle such that all of these angles in the triangle AOS is going to be equal to 180 degrees. So we're going to do the following. Angle O1, that is Q1, angle O1 is going to be equal to 180 degrees minus X, right? So it's going to be this X over here minus this X minus 180 degrees. So that we can actually get the following. Angle O, I keep saying Q, angle O1 is therefore going to be equal to 180 degrees minus, 2x. And that is what we are going to have over here. Also, this is the sum of angles in a triangle. That was our reason. So now we have the angle of O1. And remember, the question said P1 in terms of X, and that's why we don't know what the value of X is. So which means we're just gonna go as we please, basically, right? Okay. So what else do we see? What we have is this angle O1, right? Like this, and it is touching this chord over here, which is AS. Okay. So whenever we do have an angle at the center, we can maybe assume that maybe there's some angle that is actually going to the circumference, which is going to be P1, exactly what we are looking for. You can see that this angle is going to be a half of the angle at the center, or the angle at the center will be 2 times the angle here at the circumference. So how are we going to represent that? We're going to say over here that angle angle P1 is going to be equal to half of the angle at the center. Am I right? Or we could even write it like this, right? We know that O1 is equal to 2 times the angle at the so the angle at the center is equal to 2 times the angle at the circumference, which is P1. And therefore, remember, we're trying to find P1, so we're going to divide both sides by 2. And we have P1 is therefore going to be equal to O1 divided by 2. And we know what O1 is. But remember your reason over here, right? Your reason is angle at center is equal to 2 times angle at circumference. Okay, I'm just going to write it in short and you just need to write it in full. So what is O1? O1 is 180 degrees minus 2. So P1, angle P1 is equal to 180 degrees minus 2x over 2. And we can break this fraction up into 180 degrees over 2 minus 180 degrees, 2x divided by 2, right? So this is how we can break it up. P1, angle P1 is equal to 180 degrees divided by 2 minus 2x over 2. We can do that, remember, because they have the same denominator either way, and they're going to become one fraction even if you do minus them together. And now we're going to have angle P1 is 180 degrees divided by 2 is equal to 90 degrees minus, and we have these 2's cancel, therefore it's 90 degrees minus x, and that is our angle P1. Okay, so 9.2, here's our proving questions, right? We have proof giving reasons that 9.2.1 AC bisects PAS. So I'm going to say over here, okay, so let me get rid of some of this information. We know now that our angle P1 is going to be 90 degrees minus x, right? So let's look at this closely, right? We want to find out what is A. We want to prove that A2, angle A2 is equal to A1, right? Because they're saying that we need to show that AC, which is this side over here, bisects angle PAS, right? So therefore, we need to just show that angle A1 is equal to angle A2, which is also equal to x, right? So we need to prove that this is going to be equal to x. Now, how are we going to do that? So let's take note of something, right? We have an angle at the center, or sorry, a line at the center, like this. Okay, so we have a midpoint chord, right? This is what you call a midpoint chord. And we have a theorem, and I'm pretty sure a lot of us will get this theorem. If we have a midpoint chord, right, such that, let's say, for example, this is going to be the midpoint, then that means these lines must be the same. Then we have a circle center, and we have a line going towards the circle center. We know that this angle here is going to be 90 degrees. And that theorem states that the line from the circle center is perpendicular to the midpoint chord. So it's the line from the center all the way to the midpoint chord over here. So that's what we are mainly talking about here, right? So AC is intersecting that one, which is that basically that line that is a part of the is the perpendicular line towards PS. You can see it due to our theorem. But let's say this in words, right? So I'm gonna move this here, and we're gonna say that let's say PBA, because the reason why we're choosing PBA to be equal to 90 degrees is because we have the most information. We want to prove that A2 is going to be x, and we know that this is going to be 90 degrees minus x, right? And therefore, we can say that this reason is going to be line from center to midpoint chord. Okay. Cool. Or I would actually say is perpendicular to the midpoint chord, because that makes more sense. Okay, now that we've shown that, right, now we can do the following. We have a triangle PBA, right? So in triangle PBA, we have two angles. Now we can determine the third angle, which is A2, right? But let's do this. So we have, or let's just do this, obviously. We're going to find angle A2, right? And angle A2 is equal to 180 degrees minus the other angles that we know, which is going to be a 90 degrees. And then minus our other angle, we're going to keep it in brackets, 90 degrees minus x. And now we simplify even further. And our reason over here is going to be the sum of angles in triangle. Okay, that is our reason. And then angle A2 is going to be 180 degrees minus 90 degrees, which is just equal to 90 degrees. And then the minus can go into this bracket. That'll be minus 90 degrees plus x. And therefore, angle A2 is going to be 90 degrees minus 90 degrees. They cancel, and therefore we're just left with x. And therefore we've proven that angle A2 is just going to be equal to x. So then we can conclude that therefore, because AC, so I'm going to say therefore, because angle A2 is equal to angle A1, which is equal to angle which is equal to x, AC bisects angle PAS. And that is our answer for 9.2.1. So 9.2.2 says the following. COR, so we need to prove that COSR is a cyclic quad. Okay, so they're talking about COSR over here, right? So it only has 2 points on the circumference and only has 1 point on the circle center and just a random point C. Okay, so it's not a circle center exactly, because once again it's not all four sides that are on the circumference. Okay, so from here what we're going to be doing is we need to look for the information that we have, right? So let's look at our actual circle center that we have, right? Maybe we can get some information from there. So let's look at this angle A, PAS. So we have angle PAS equal to 2x, right? Because we're adding this x and x together over here. And we have, of the cyclic quad, angle R. And we can actually determine angle R, which is a part of our other cyclic quad we're trying to prove. So let's find out what angle R is. So here we can say that angle R is going to be equals to, and remember that in a cyclic quad, the opposite angles must add up to 180 degrees, right? So which means we say angle R plus angle PAS must equal to 180 degrees. And this is, the reason is op angles of cyclic quad. Okay, that's our reason. And we just need to substitute our values in over here, or our variables in this case. We know that angle R is just adding with, what is angle PAS? It's just 2x, right? We already said it was 2x, so it's going to be 2x equals to 180 degrees, right? And here we can just say that angle R is therefore going to be equal to 180 degrees minus 2x, because we're taking the 2x to the other side. Okay, so now there's our angle R. Our angle R is 180 degrees minus 2x. And now we need to find O2. Can you see over here that if we find O2, therefore we can prove that the sum of these two opposite angles are going to equal to 180 degrees in fact. And if that is going to be true, then we can actually show our working over here. Okay, so what we are going to be doing here is we are going to say that how do we actually get O2? So we can see that O2 is in line, or is on a straight line, right? With what other angle? O1. It is in a straight line with O1, and we know what the value of O1 is. O1 is just equal to, if I can remember clearly, it was 180 degrees minus 2x, right? When we looked at the value. Okay. And then from this, we're just going to find out what angle O2 is. So if we add O1, so angle O1 plus O2, we are going to get 180 degrees because it's angles on a straight line. Okay, sorry about that. The dog is going crazy here. Okay, so what we have over here is that if we add these two together, we know what O1 is, right? O1 is 180 degrees minus 2x. So let's first take this over to the other side, right? And if we do that, we're going to have O2 on its own, angle O2, 180 degrees minus that. And what was our angle O2? It was 180 degrees minus 2x, if we can still remember that. And now we can just simplify even further. It's going to be 180 degrees. The minus goes into the bracket, and we're going to have minus 180 degrees plus 2x, right? And therefore, we're going to have angle O2 equal to, these cancel, and this is going to be 2x. And there we go. Now we have angle O2 equal to 2x, right? So we are getting somewhere. It seems that we are on the right track right now. So if we add these two angles together, angle R and angle angle O2 and angle R, we should get 180 degrees. So let's test that over here. So let's just do that then, right? So if we are gonna add angle O2 and angle R, we must get 180 degrees, right? So that's what we are going to try and prove. So let's do that. If we do this, right, so we're going to write equals over here. We know that O2 is equal to 2x, and we're going to say plus, and our bracket here, we know that R is equal to 180 minus 2x, right? 180 degrees minus 2x. I'm pretty sure we can see it already. And then we can actually write as 2x plus 180 degrees minus 2x, and these two x's will cancel, and therefore we'll get 180 degrees. So that means we can conclude that therefore, which one was a cyclic quad? COSR is a cyclic quad. And remember, we need a reason over here. It was the converse opposite angles of a cyclic quad.